Welcome, y'all. It's just math, y'all, and here we are today. We're going to talk about um, exponential expressions. We're going to have dealing with exponents. This is section 4.1 and 4.2 in our book for Math 100. Okay, so let's look at what we have here. So first of all, we're going to go 4.1 and 4.2. These are the exponent rules. But before we get started, we need to look at our definitions. We have what we call a base. In this problem, 3 is our base, and 4 is the exponent. And 3 to the 4th is called a power, and of course 81 is also a power. And just to remind you what exponents mean. So we're going to get into our rules for multiplying and dividing exponents with expressions with exponents. These are powers. We're multiplying powers. And so the first one is called the product rule. If you want to stop the video and copy down these examples and see if you can remember how to do them from maybe a previous lesson, and then start back the video when you're ready. But here we go. We're going to go through these particular examples using the first rule. The first rule is the product rule. And it basically says when multiplying powers, you can add the exponents when these guys are alike. For example, these are both a's, and so they are alike. All right, so when I have an x to the 3rd times an x to the 4th, that's going to give me an x to the 7th. And for the second example, I've got numbers, and I've got a 3 times a -2, which is a -6. X to the 5th times x to the 4th is x to the 9th. And then this last example I can do on my numbers, just regular. And so that's going to give me a -2 times 4 is -8. -8 times -3 is -24. And then for the a's, I'll add those, and I'll have a to the 5th. And then the b's, now let's look. The first b does have an exponent. It's an exponent of 1. So we need to remember that. And so that'll be a b to the 4th power. And then the c's, again, there's a 1 on that one. And I've got 11 c's. Now, basically what's going on here behind the scenes, just a little, no tricks. This is kind of a trick, but I don't want everybody to think everything's a trick. We've got here x to the 3rd is 3 x's multiplied together, and then x to the 4th is 4 x's multiplied together, and so obviously that gives me 7 x's multiplied together. So that's what's going on when you understand what exponents mean. So in summary, for this guy, for our first rule, in summary is when multiplying powers that are alike with alike bases, you can add the exponents. So there's that little trick in there. All right, let's go to the second one. The second rule is called the power rule. And so basically you're raising a power to a power. So when raising a power to a power, okay, all right, let's see what we do. So when raising a power to a power, it looks like we're going to multiply the exponents, okay, multiply the exponents. So now this first one, if I multiply 3 and 4, I'll get x to the 12th. So now let me explain that a little bit. Let me take that and just explain that, how I got that. So if you know what the 4 means, it means that there's 4 x to the 3rds. That's what the 4 means. And then the little 3, well, we know what those mean. It means that those are 3 of those. And so everything's multiplied together. And so I'm looking at 12 x's being multiplied together, which is how I get x to the 12. So that's what's going on behind the scenes. Okay. So shortcut, when taking a power and raising it to a power, then we can multiply our exponents. Now let's look at this next one. We have 3 to the 4th, 3x squared to the 4th power, so that would be 3x squared, 3x squared, 3x squared, and 3x squared. Okay. And so that would be, sorry, the timer tells me to stop. So that would be 3 of those, or 3 to the 4th, and then x, 1, 2, I think there's 8 of them. Yeah, so x to the 8th. So that would be 3 to the 4th, x to the 8th. And now 3 to the 4th, if you remember on a previous slide, it's 81. So this will be 81 x to the 8th. Now, here's a little shortcut. Let me show you that. So we can kind of do a little distribute here. And so again, there is a 1 on that 3. It does have an exponent. So that would be 3. 4 times 1 is 4. And then that would be 2 times 4 is 8. And so there is the red, you have the shortcut. Orange is the long cut. Both ways are correct. Think them through. You don't have to do the orange method every time. It's just trying to get you to see the shortcuts. Okay, so let me finish this last example and we'll call this one. All right, we're going to do the shortcut for this one. I don't want to write all this out. This looks pretty big. Remember, there is a 1 on that. There is a 1 on that one and a 1 on that one. And there's a 1 on that one. What about that negative? What about that negative? Well, let's make that a negative 1. All right, and there is a 1 on that one as well. So this is going to be negative 1 to the 3rd, 3 to the 3rd, a multiplying to the 9th, b multiplying b to the 18th. Okay, let's do the next one. This is times 2 to the 4th, a to the 4th, b to the 20, and c to the 4th. Okay, so now let's do what we can. Let's put the ones together that are alike. So now we've got these two. Now we're multiplying now. Remember, we've done that first part. Now we're multiplying. So now we can add those two. So those two would give me a 9 plus 4 is 13. And then the b's would give me a 38th power. And the c's only have one c, so c to the 4th. All right, now my numbers. I have 2 to the 4th, which is 16. I knew that one. You might not have known that. And 3 to the 3rd, which is 27. I'm going to multiply those together. And then I have a negative 1 to the 3rd, which is negative 1. So I'm going to multiply those three together. I'm going to get a negative. I got to do 20. I think it's what? 432 maybe? 432. Let's see. 3, 2, 3, 2, 2, 2. So yeah, that's 6. Yeah, 432, and then times a negative 1. All right. Hope that's right. So there we go. All right. So now when raising a power to a power, you're going to do what? You're going to multiply the exponents. All It's just math, y'all.